is RSN, real science now. Let's dive right into the show.
Theory Thursday, the wacky world of quantum mechanics. Welcome to Theory Thursday, where we dive into the mind-boggling theories that make the universe a truly weird place. Today, we're going to unravel the quirks and oddities of quantum mechanics, a field of science so peculiar it might make your brain do a double take. Imagine if your favorite science fiction novel came to life. Well, quantum mechanics is like that, but with equations and a lot more confusion. So, buckle up as we journey through the bizarre and fascinating realm of the quantum world. Let's start with a fun fact. If you were to shrink down to the size of an atom, the world would look like a giant, chaotic carnival. Picture this: electrons zipping around like bumper cars, and particles popping in and out of existence like the most unpredictable carnival games you've ever seen. This wacky carnival is the quantum realm, where the rules of everyday life seem to go out the window. The story of quantum mechanics begins in the early 20th century with a young physicist named Max Planck. Max was like the Sherlock Holmes of the atomic world, trying to solve the mystery of black-body radiation, an issue that had stumped scientists for years. Imagine you're at a cookout, and you're trying to figure out how a hot grill radiates heat. Max Planck was doing something similar, but with fancy equations. His breakthrough came when he suggested that energy wasn't continuous, but rather came in discrete chunks, which he called quanta. Think of quanta like tiny energy packets that are as small as popcorn kernels in a kettle. This idea was the spark that ignited the quantum revolution. Then came Albert Einstein, who decided to crash the quantum party with his own theory. In 1905, Einstein published a paper explaining the photoelectric effect, where light hitting a metal surface ejects electrons. He proposed that light isn't just a wave, but also comes in particles called photons. Imagine photons as tiny, invisible marbles that could knock electrons out of their orbits. Einstein's work added more fuel to the quantum fire and earned him the Nobel Prize. It was like being awarded the gold medal at the Quantum Olympics. As the quantum party grew, more guests arrived. Enter Niels Bohr, the life of the quantum party, who introduced the Bohr model of the atom. Bohr's model was like a new theme park map for the atomic carnival. He suggested that electrons orbit the nucleus in specific shells or energy levels, sort of like planets orbiting a sun. But here's the kicker: electrons could jump between these energy levels, emitting or absorbing energy in the form of photons. It was like watching a cosmic light show with electrons dancing between different energy stages. But the party didn't stop there. Along came Werner Heisenberg, who threw a wrench into the quantum festivities with his uncertainty principle. Imagine trying to take a selfie with a ferret on a trampoline. The more accurately you try to capture the ferret's position, the less you can pin down its speed. Heisenberg's principle says something similar about particles. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. This idea was so mind-bending that it left scientists scratching their heads and wondering if they'd accidentally taken a wrong turn into a surrealist painting. Then there's Erwin Schrödinger, who gave us one of the most famous and amusing thought experiments in quantum mechanics. Schrödinger's cat. Imagine a cat in a sealed box with a radioactive atom and a vial of poison. If the atom decays, the vial breaks, and the cat is doomed. If it doesn't, the cat remains unharmed. According to quantum mechanics, until you open the box, the cat is both alive and dead at the same time, a state called superposition. It's like the ultimate quantum gamble where the stakes are your feline friend's life. Schrödinger's cat was his way of illustrating how particles can exist in multiple states until observed, although he didn't really intend to put any cats in boxes. Phew! Now, let's talk about a quirky concept called quantum entanglement. If you thought the idea of a cat being both alive and dead was strange, wait until you hear about particles that are entangled. Imagine you have two magic dice, and no matter how far apart you roll them, they always land on the same number. That's entanglement. Two particles become linked, so the state of one instantly affects the state of the other, even if they're light years apart. It's like having a cosmic buddy system where your particles share secrets across the universe. Einstein famously called this spooky action at a distance because it seemed to defy the usual rules of space and time. As we delve deeper into quantum mechanics, we encounter the concept of the observer effect. This is where things get really trippy. According to quantum theory, simply observing a particle changes its behavior. Imagine you're trying to catch a firefly in a jar. The moment you shine a light on it, the firefly might dart off in a different direction. In the quantum world, particles act differently when you're watching them, which leads to the idea that reality is influenced by observation. It's like the universe is a giant stage play where the actors are aware of their audience. To further spice up our quantum adventure, let's explore quantum tunneling. Picture this. You're a particle trying to pass through a wall. In the classical world, you'd need to climb over or break through it. But in the quantum world, particles can sometimes tunnel through barriers as if they're ghosts passing through walls. This phenomenon has practical applications, such as in the workings of modern electronics like tunnel diodes and scanning tunneling microscopes. It's like having a quantum superpower that lets you sneak past obstacles. Quantum mechanics also introduces the concept of wave-particle duality. This means that particles, like electrons and photons, can behave both like waves and like particles. Imagine a beach ball rolling through a crowd. It's a ball, particle, that bounces around, but if you look at its wave-like motion, it spreads out like ripples on water. This duality shows that particles don't fit neatly into one category. They're more like shapeshifters that defy our everyday understanding. One of the most mind-bending aspects of quantum mechanics is the idea of the quantum multiverse. This theory suggests that every possible outcome of a quantum event creates a new, parallel universe. Imagine you're deciding whether to have pizza or burgers for dinner. In the quantum multiverse, there's a universe where you had pizza, another where you had burgers, and countless others where you made different choices. It's like living in a vast multiverse where every decision spawns a new reality. While it sounds like science fiction, it's a serious concept that physicists explore to understand the nature of reality. As we approach the end of our quantum escapade, let's reflect on the impact of quantum mechanics on modern technology. Quantum theory isn't just about mind-bending ideas, it's also the foundation for many cutting-edge technologies. Quantum computers, for example, promise to revolutionize computing by harnessing the power of quantum bits, or qubits, which can be in multiple states simultaneously. This could lead to breakthroughs in fields like cryptography, drug discovery, and complex problem-solving. Quantum theory also underpins technologies like MRI machines and lasers, making it an essential part of our modern world. In summary, quantum mechanics is a field that challenges our understanding of reality and defies conventional logic. From Schrödinger's cat to entangled particles and quantum tunneling, the quantum world is filled with astonishing and perplexing phenomena. As we continue to explore and unravel the mysteries of quantum mechanics, we gain deeper insights into the nature of the universe and our place within it. So, next time you find yourself pondering the strange and wonderful workings of the universe, remember that quantum mechanics is like the ultimate cosmic carnival, where the rules are anything but ordinary, and the adventure never ends. Embrace the weirdness and let your imagination soar as we venture further into the extraordinary realm of quantum physics.
That's a wrap for this episode of RSN Real Science Now. Thanks for tuning in, science lovers. Keep questioning everything and explore the world around you. We'll be back with more mind-blowing facts soon. Until then, stay curious.